Hello, this is Ms. DB, and today we are going to learn how to divide rational expressions. This is finishing up the Chapter 8, Section 2 assignment, so we're on Part 2. We already did simplify rational expressions, but we always will be doing that with these problems. And we did the multiply, and today we're going to divide rational expressions and solve simple rational expressions. So simple, actually this should say equations. Solve simple rational equations, so they'll have an equal sign in them. All right, so when we divide by a fraction, you multiply by its reciprocal. So when you take one, if you want to take 1/2 divided by 3/4, you really are going to do 1/2 times 4/3, and then you can cancel anything that's common factors, and then you write your simplified answer. We're going to do that today. We are going to change it to multiplication. We're going to factor any common factors, and we also would have to say what y or x cannot be, but it says assume that all expressions are defined, so we don't have to worry about that for these. So first of all, switch it to multiplication. Second, look for common factors. Like right away I'm like 8 and 8, they can cancel. 5 goes into 15 3 times. Now for what's left, you can write it out all together, so we'd have on the bottom x squared over y squared. Don't forget there's going to be a 3 left in the denominator, and then you can simplify, or you can work on it as it is. So x to the 4th over x squared, those go together. Remember, they have to have the same base. And y to the 5th over y squared, those can be simplified. So that is going to leave x squared y to the 3rd in the numerator and 3 in the denominator. You may want to write that as 1/3 x squared y to the 3rd. Either way is perfectly acceptable. All right, in these problems you have to factor first. First, look for any common factors that can be factored out, and then look if you have trinomial factoring or difference of squares, and see what you can do. Don't forget to change this to multiplication as well by switching where the numerator and denominator are. So then we start factoring just like we did with simplifying and multiplication. All right, so they've already factored out the common factor from this part, and we got x squared times x squared minus 9. There's also a common factor in this denominator, and that is x squared as well, so they factor an x squared out, and we're left with x squared plus 2x minus 8. This and this are both difference of squares. And then this and this is trinomial factoring. So lots of factoring practice. So we have x squared times x minus 3, x plus 3. That's the difference of squares. On this section right here, the factors of 3 that equal a -4, would 3 times 1 doesn't work because that'd be +4 when you add them. So we have to use -3 times -1. So we put in our x minus 3, x minus 1. And then over on the right side, x squared minus 16 is a difference of squares. So you can go x minus 4, x plus 4. And then don't forget to rewrite your x squared here. We have to factor x squared plus 2x minus 8. So -8 factors into -4 times 2. We need the one that will add to be a plus 2, so that doesn't work. Or we could do 4 times -2. That works. So when you find the one that works, you put a +4 and a -2. Now we're ready to look for common factors. We have an x minus 3 over x minus 3. Those can cancel. X plus 4 over x plus 4. Those can cancel. And then an x squared and an x squared. Note that you can never cancel if you have one as a plus and one as a minus, like x plus 4 and x minus 4 would not cancel. These two here would not cancel. And then when you're done canceling everything, you write what you have left. You can leave your answer like this, or if you prefer, you could FOIL this back together. Here's just a sample problem. These are a little simpler when you just have monomials. Remember to change this to multiplication, and then look for things that can factor. Use your properties of exponents if you have the same base in the numerator and the denominator. You can subtract their exponents. Remember that we will leave the exponents as positive, so if you have a greater number as an exponent in the denominator, you will end up with that base in the denominator. So all of this would factor as 3y over x squared. Here's an example where you have to do lots of factoring. Pause the video and try this one, and then come back and see if you got the right answer. This one's a trickier one. So the trickiest part of this one is factoring this 2x squared minus 7x minus 4, and this part. Once you factor out the 4, you have a fairly complicated trinomial factoring. So if you can see what the answer is here, the minus 4 times 1 is what worked, and the 2x here. You might have to try a couple things to get that to work. How about this one, 2x squared minus 7x plus 3? I know I'm going to need a 2x and an x, but I'm not sure if I want it to be plus 1 plus 3. That's not going to work because I need a negative 7. So I know that at least one of these needs to be a minus sign. Actually, they both need to be minus because I'm going to end up with a positive 3. The only way to get a positive 3 for my last term is going to be negative times negative or positive times positive, which I already know won't work. So we'll try this and see. So to FOIL, you take first times first, that's 2x squared. Outer is negative 3 times 2x, that's minus 6x. Inner is negative 1x, that's looking good. And then last times last, negative 1 times negative 3 would be a plus 3. And then you combine the like terms for your middle terms, and we do get negative 7x. So that worked. So our first try worked, which is great. So then our factors for this are 2x minus 1 and x minus 3. Once you've factored everything, then you can start canceling any common factors. Excuse me. And then we are left with, let's see, those cancel, the x minus 3's cancel. We're left with just 4 times x minus 4 over x plus 3. So this big giant mess, lots of different things going on, simplified to kind of a nice, neat little problem, which is why these are fun. So on your assignment, you're going to do these problems. Number 1 and 2 have been started for you. I've already changed them to multiplication, and then you can look for common factors. On number 2, I should probably put parentheses around the x plus 4. Those are factors, and the whole factors can be canceled. Let's look at one of the tricky ones like number 5. In number 5, we have to factor. I didn't put as many hard to factor trinomials as are on the examples on your homework. So we need to factor x squared plus 2x minus 3. We've done this one before. That factors into x minus 1, x plus 3, which I know because the factors of negative 3 that equal a positive 2. We can't use negative 3 and 1 because that would give me a negative 2, so I have to use 3 and negative 1. X squared minus 9, we've done that one. That's x minus 3, x plus 3. That's a difference of squares. You might want to write these ones down on a list of how to factor certain ones that keep popping up over and over again. That's not supposed to say equals, it's supposed to say divide by. But I'm going to change it right to times right now, and I'm going to switch this to the reciprocal. So on the top, I would have x squared minus 2x minus 3. Let's factor that. The factors of negative 3, that would equal a negative 2. Well, I've got my factors of negative 3 written over here. I just need the negative 3 and the 1 this time. And then the factors for this one will go in the denominator. So negative 4. The factors of negative 4 that would equal a positive 3. No, that'd be negative 3. How about this? That's the same exact thing. No, that's right. That'd be a positive 3. So x plus 4, x minus 1. Once you write everything as factored, now you can look for anything that would cancel. So I've got an x minus 3 and an x minus 3, x plus 3, x plus 3, x minus 1, x minus 1. So all I'm left with is the x plus 1 over x plus 4. Remember that if you are typing this, to use your parenthesis key, the slash key for division, make sure you put the denominator in parentheses. So write like that.